Today, I'm looking at Alpha Impulsion, a French startup that's working on a new propulsion system that they claim has much better performance than conventional liquid rocket engines. Alpha Impulsion was founded in 2022 and is based in Toulouse, with some activities in Italy. Their Autophage propulsion system has the potential to dramatically lower propulsion costs, with fewer moving parts and a simpler vehicle architecture once the technology matures. They have plans to develop both a small rocket launcher and an in-space thruster, targeting orbital mobility and small mass to orbit markets. Now we know a little about the company, let's cover the key piece of technology, the Autophage engine. Autophage space propulsion. Autophage means self-eating. The rocket literally consumes itself, or to be more precise, the propellant structure is burned away, leaving behind the engine, payload, and other non-consumable components. The Alpha Impulsion Autophage engine features a solid fuel tube with a liquid oxidizer sealed in its core. Two pistons push the tube into the combustion chamber, where a catalyst converts the oxidizer into hot gas. This gas then reacts with the solid fuel, generating thrust. This approach differs from traditional solid rocket motors in an important way. Because it's a hybrid system, the engine can be throttled and restarted. That capability is essential for many orbital and in-space missions. It also offers potential advantages over conventional hybrid engines. There is no need for a separate oxidizer tank, extensive plumbing, or a heavy fixed casing around the solid fuel, since the oxidizer is integrated within the consumable structure itself. The structure is the fuel. Similar to a candle consuming itself when burning, an autophage engine results in the launcher consuming itself during flight. The difficulty in this type of system is finding a substance that can serve as both fuel and structure. Alpha Impulsion uses HDPE, or high-density polyethylene. It's a common and cheap plastic that can be produced in a long tube shape, perfect for a rocket fuselage. It's non-toxic and safe to handle. For a small rocket, HDPE can provide adequate structural strength. However, scaling the design to a larger vehicle would likely introduce challenges. Issues such as buckling and creep could cause the tube to deform under load, which is one of the reasons autophage propulsion is currently more suited to micro-launchers than to medium or heavy lift vehicles. Infinite stage to orbit. You can think of an autophage rocket as having infinite stages. Because the structure itself is consumed as fuel, the vehicle is continuously losing mass throughout the burn. Let's examine this concept in a little more depth. The continuous mass reduction improves efficiency because the rocket is not carrying dead weight all the way to orbit. In a conventional rocket, empty tanks and structural mass must be lifted the entire way, even though they no longer serve any purpose after their propellant is used. By turning that structure into propellant during the flight, an autophage vehicle maintains a more favorable mass ratio throughout the ascent. According to Alpha Impulsion, this approach can deliver almost twice the efficiency of a conventional rocket. The company refers to this concept as ISTO, or Infinite Stage to Orbit. Simpler vehicle architecture. The best part is no part. Autophage systems are simpler in comparison with rockets that use liquid engines. No turbopumps, no cryogenic systems, and no heavy propellant tanks to contain the fuel. It has to be mentioned though, it does require a piston system to push the solid fuel tube into the combustion chamber. This introduces a mechanical system that adds a new source of risk that traditional liquid or solid rockets do not have. It's also worth noting that reusable launch systems face a different set of challenges. Features such as landing legs and other recovery hardware add mass, which in turn requires additional propellant and structural reinforcement, increasing the overall complexity and weight of the vehicle. No staging. Because the vehicle structure is continuously consumed as fuel, there is no need for traditional staging. This removes the requirement for separation systems, which adds complexity and potential failure modes. In addition, staging systems add mass and require additional mechanical components. No pressurization system. Another advantage of the autophage approach is that there is no need for a traditional system to keep the propellants under pressure. In Alpha Impulsion's design, the liquid oxidizer is stored inside the solid fuel structure itself, removing the requirement for large separate tanks and the associated pressurization systems. Tank pressure problems have contributed to failures in several rocket programs. Issues such as structural buckling, propellant feed interruptions, or sloshing can occur when pressure is not properly maintained. By integrating the oxidizer within the consumable structure, autophage systems aim to eliminate these particular failure modes, along with the added mass and complexity of pressurization hardware. For example, a 2025 ground test of a Starship prototype at the Massey site in Texas ended in an explosion, which was caused by the failure of a composite overwrapped pressure vessel. Events like this highlight the risks associated with high-pressure systems. Timeline and development status. In May 2025, Alpha Impulsion successfully conducted a static fire test of the world's largest autophage engine. The 17-second test took place in southern France and demonstrated stable, controlled combustion. The structure remained intact under operational pressures, and the seals held, confirming the correct functioning of their oxidizer filling procedure. This progress contributed to Alpha Impulsion being awarded approximately €1 million by the European Union in early 2026 through the Prize for Game-Changing Innovation. The funding is intended to support the development of an optimized 1 kN class engine. The company has stated that their current engine achieves a specific impulse of around 300 seconds. Future testing is expected to focus on improving both thrust and efficiency as they work towards higher performance versions of the engine. Grenat, Alpha Impulsion's autophage launcher. Alpha Impulsion is developing a small orbital launcher called Grenat, which they hope to fly later this decade. The vehicle is 25 meters tall with a diameter of around 1 meter. Depending on the launch site, it is designed to deliver up to 1,000 kilos to low Earth orbit. One of the most distinctive features of an autophage rocket is that the vehicle would visibly shorten during flight, as its structure is consumed as fuel, essentially burning like an upside-down candle. Alpha Impulsion believes they can cut manufacturing costs by 80%, bringing dedicated launches down to rideshare prices. This is because the rocket structure is the fuel, which is just a simple tube. The propellant is HDPE and liquid oxygen, both of which are cheap, resulting in a low-cost vehicle. With SpaceX's rideshare flights fully booked until the end of 2028, new bookings are closed for the next couple of years. While Starship will eventually provide very low rideshare flights in the future, there is a window of opportunity for new operators to offer low-cost missions to customers that would normally have flown on a Falcon 9 rideshare flight. Alpha Impulsion has also referenced a 13-ton class micro-launcher capable of delivering around 500 kilos to orbit, a higher payload than Rocket Lab's Electron. The company plans to achieve low unit costs through high-volume production, eventually building hundreds and later thousands of engines per year. The vehicle itself will consist of the engine, a fairing, and a simple plastic tube structure. Alpha Impulsion is targeting a price of around €4,600 per kilogram, which would bring dedicated small launches close to current rideshare pricing. Opal, Autophage in-space thruster. Opal is Alpha Impulsion's in-space autophage thruster. Because it's a hybrid system using liquid oxygen as the oxidizer, the engine can be throttled, stopped, and restarted, capabilities that are important for orbital maneuvering and deep space missions. The engine is designed to produce around 1 kN of thrust, which would make it suitable for use as a space tug. UK-France partnership. an early path to space for Opal. Meridian Space Command, a UK company based at Spacepark Leicester, is developing a low-cost orbital transfer vehicle known as the Economical Transfer Vehicle, or ETV. What makes this vehicle lower cost is the use of the highly efficient Opal thruster. Since the structure of the vehicle is also the fuel, the dry mass of the space tug is much lower. This results in improved performance and the ability to deliver higher delta V, allowing payloads to be moved between orbits or even sent on higher energy trajectories towards the moon or deep space. The partnership also offers Alpha Impulsion an early opportunity to gain flight heritage for the Opal thruster. Demonstrating the engine in orbit on a dedicated space tug mission would provide valuable real-world performance data and help build credibility ahead of its use on larger vehicles such as Grenat. The UK Space Authority awarded £150,000 to support the project. Potential missions for Opal. Alpha Impulsion's Opal thruster is designed with several mission types in mind. Let's look at the main ones. Orbital raising is one of the most common requirements for in-space propulsion. After a satellite is deployed into an initial orbit by a launch vehicle, it often needs to be moved into a higher or more precise orbit. This could include raising a satellite into geosynchronous orbit or adjusting its position within a constellation. Interplanetary transfers represent another potential application. A high-performance thruster like Opal could be used to deliver payloads on deep space trajectories, whether for lunar missions, Mars exploration, or other scientific objectives beyond Earth orbit. Space tugs and orbital surfacing are expected to become increasingly important in the coming years. With the rapid growth of mega constellations, there will be a rising need for vehicles capable of moving satellites between orbits, extending their operational life, or removing them at the end of their mission. As thousands of satellites are deployed into similar orbital planes, even low failure rates will result in large numbers of defunct spacecraft. Pressure from regulators is increasing, with many space agencies now requiring satellites to be deorbited within 5 years of the end of their mission. Space tugs could play a key role in active debris removal, helping to reduce the growing risk of collisions in heavily used orbits. In addition to deorbiting, space tugs could support higher value missions such as space situational awareness, satellite imaging, or on-orbit refueling and repair. Market segment comparison. The in-space mobility market is less crowded than the dedicated small launcher market. While the market is growing, it's still a niche market with a high growth potential. Key demand drivers include constellation management, in-orbit servicing, active debris removal, and in-space logistics. Some of the established players are Impulse Space, OrbitFab, Astroscale, D-Orbit, and Momentous, but there's still room for new players. With flight-proven hardware, companies can charge prices with healthy margins, especially to risk-averse clients such as governments and customers deploying high-value payloads. The small launcher market, on the other hand, is extremely competitive. Dozens of new entrants worldwide are looking to offer services to launch small-mass payloads. Some of the players are Firefly, Skyrover, Gilmore Space, High Impulse, ISA Aerospace, RFA, PLD Space, and the list goes on. With this level of competition and downward pressure on prices, it's hard to see how any company can make a profit in this sector. Even Rocket Lab, the current market leader in small satellite launches, now generates the majority of its revenue from space systems, satellite platforms, and related services rather than from launches. Starting with Opal makes strategic sense. Demonstrating the Opal thruster on a space tug provides an early path to validating their hardware works in the environment of space. Either with their own platform or partnering with another company, such as Meridian Space Command, provides a quick way to gain flight heritage. A space tug using the Opal thruster would demonstrate reliable restarts, throttling, and the concept of an autophage engine in orbit. This de-risks the technology and makes it more attractive to risk-averse customers, An in-space demonstration is less expensive than launching a rocket, with less licensing and environmental requirements. The development cycle is also faster, allowing the company to iterate on performance and reliability more quickly than would be possible through a full launch vehicle program. This strategy would also generate interest from European national space agencies, many of which are seeking sovereign capabilities in areas such as space situational awareness, satellite inspection, and on-orbit servicing. Final thoughts. Alpha Impulsion is currently focused on maturing its engine technology and transitioning from research and development toward commercial operations. The company has raised over €2 million in funding and is actively expanding its team. A dedicated launcher that can deploy payloads for rideshare prices could provide an alternative to SpaceX's transporter missions, especially considering these flights are now completely booked for the next couple of years. It will be interesting to see if Alpha Impulsion can qualify the Autophage thruster this year, leading to an in-space demo mission perhaps in 2027. Their Grenat launcher's first flight could follow later in the decade. What do you think of the Autophage concept? Do you think this self-eating rocket will provide efficient launches to space? Leave your thoughts and opinions in the comments section below. Thanks for watching. If you enjoyed this space video, consider buying me a coffee to help fund more episodes like this. The link is in the description. Be sure to like and subscribe so you'll see our upcoming videos. We make videos every week covering the space industry with an emphasis on the smaller space startups that aren't covered so well on other channels. See you soon.